Hello friends, my name is Baji. Welcome to our channel. This is episode number 6 in our performance testing must have skill series. In this video, we will continue to discuss server architecture concepts. If you watch this series for the first time, please watch previous videos of this series and continue these concepts. You can find the link to this playlist series in the description. Let's start with the topics covered in this video. First, we will discuss the topic of architecture. Then we will discuss what exactly the software architecture is, and then we will discuss different layers of the application. Finally, we end this video by discussing about the different software architecture patterns. These days, there are many patterns available. However, I will be focusing on common patterns used by many companies. So without wasting any time, let's dive into it. So what is architecture? Basically, it is the art and technique of designing or building something that is well suited for its purpose. The person who is designing the architecture is called architect. So it could be designing an apartment building or an individual house. Here, the purpose of designing an apartment building is to provide accommodation to a lot of people. Similarly, the purpose of designing the individual home is for the family to live in. In both cases, the architecture will understand the requirements and design it accordingly. Some people will also refer to architecture as a blueprint of the building, as it shows the overall structure of the building and different components of the building. So now let's try to understand what a software architecture is all about. Similar to the architecture definition, it is also a technique of designing software that is well suited for its purpose. Here, the architect will design the software architecture based on the client's requirements. If you take e-commerce or banking application as an example, the purpose of the e-commerce application is to allow users to shop online, browse product catalogs, create wish lists, add items to their cart, and complete purchases. Similarly, the purpose of the banking applications is to allow users to checking their balance, transferring funds to another account, paying balances, etc. Here as well, the software architecture is called the blueprint of the software. It shows the overall structure of the software, the collection of components in it, and how they communicate with one another. Now let's talk about different application layers. Each of the layers in the application has a specific role and responsibility. For better understanding, I try to simplify the concepts. You may be finding different versions of this concept. Just try to understand its purpose and the role it plays in the architecture. Okay. Presentation layer. This is the layer that the clients will see and interact with when using the application. The layer will help the clients to communicate with the application. The clients will pass the necessary information in the form of keyboard commands or mouse clicks, etc. For example, to log into the Facebook application, we will give the username and password, and then we'll click on the login button. So we are communicating with the Facebook application to validate the credentials and allow us to log in to the Facebook to check our feed. In recent years, these presentation layers gets more complicated because we have access to very robust front-end frameworks like AngularJS and React.js, which are handling a lot of business logic in the presentation layer itself. The next one is the business layer. This is also known as the application layer. It contains the business logic and other rules that help this layer to communicate or exchange the responses between different layers. This will act as a bridge between the presentation layer and the data layer. When the user submits a request through presentation layer, it validates the request and processes it and passes this data to data layer. Similarly, once it has the required data from the data layer, and it will pass the information back to the presentation layer. The next one is the data layer. The data layer stores and manages the data of the application or software processes. It will take the inputs from the business logic layer and respond back with the requested data. In general, the business logic layer will send the request to the data layer in the form of queries. These queries will be written using structured query language. Now let's talk about software architecture patterns. Before exploring the different software architecture patterns, it is important to understand what a software architecture pattern is. So let's quickly explore it. Basically, it is a predefined pattern to organize the software components in software architecture. There are different ways to organize the components in the software architecture. In each pattern, the components are organized differently for meeting the client's requirements. There are many types of software architecture patterns, and again, I would like to focus on commonly used patterns in this video. If you are interested in a specific pattern that is not covered here, please feel free to post it in the comment section, and I will try to create a separate video for that pattern. Now let's quickly look at the software architecture patterns that are going to cover in this video. I'll try to cover monolithic architecture, multi-tier architecture, microservices architecture, event-driven architecture, and serverless architecture. Now let's discuss the first architecture pattern, which is monolithic architecture. Here, mono means single and lithic means a stone. It is a traditional model of software deployment which is built as a single program from a single platform. In this type of architecture model, all three layers such as the presentation, business logic, and data layer will reside in a single instance. Here, all the required services are tightly coupled together. Now let's look at some of the advantages and disadvantages of this model. The monolithic application is a single centralized unit. Therefore, it is easy to develop and deploy. In addition to that, in case of any issues, it is easy to debug as well. Also, end end-to-end testing can be performed faster in comparison with other architecture models. Managing a monolithic application is less complex because we don't need to manage complex infrastructure and all the code is resided in a single instance. This will help the team to focus on the business requirements and build a better version of a product. The monolithic approach is more suitable when designing a simple application because it uses a single code base and framework. Despite some benefits, there are some drawbacks to this type of model. Since this type of model operates on a single code base and any changes must involve the entire architecture, that includes scaling the application. So it is impossible to scale only one segment. For example, we cannot scale business logic layer alone. In this model, the applications are tightly coupled to each other. That means if something goes wrong with one functionality, and it will impact the entire application, and even sometimes the application will crash. In case of any new technology integration, the whole architecture needs to undergo a code rewrite. This may increase the time and effort. Now let's discuss multi-tier architecture. As the name implies, there will be multiple tiers in the architecture. This is also referred to as a layered architecture pattern. Before discussing any further, let's quickly try to understand what is a tier. Basically, tier refers to a functional division of the software that runs on infrastructure separate from the other divisions. In simple words, we can also say in one tier we will have an individual running server. In some situations, several servers may also be counted as one tier. In a monolithic model, all the layers will be deployed on a single tier. Because of the challenges, they come up with this multi-tier model where they separate the layers onto different servers. The way they organize the layer will form a pattern in the multi-tier architecture model. Now let's discuss those different multi-tier architecture patterns. The first type of pattern is two-tier architecture. In this type of architectural pattern, the layers will be deployed in two tiers or servers. This is also referred to as the client-server architecture model. Again, in this specific pattern, the layers will be organized into two different ways. In the first type, the presentation layer will be organized on the client side, and another two layers such as business logic layer and data layer will be organized onto the server side. This is also referred to as thin client as most of the logic processing will happen on the server side. In the second type of two-tier architecture pattern, the presentation layer and business logic layer will be organized in the client and the data layer will be on the server. This is also referred to as a thick client as the heavy processing will be on the client side. Office 365 or Microsoft Outlook are examples of this type. Now let's look at the next type of pattern in the multi-tier architecture model. This is also referred to as three-tier architecture pattern, and it is popular architecture model. Even though there are so many new patterns, some organizations are still following this three-tier architecture pattern. In this model, all three layers such as presentation, business logic, and data layer will be organized in an individual server. This will allow a clean separation between types. By isolating the layers, they become independent from one another. For example, if we want to change the database from an Oracle server to SQL server, we can easily change it without impacting any other layers. The next pattern in the multi-tier architecture model is N-tier. Here, the number of tiers will be organized based on the need and requirement. In this type of model, we can have multiple tiers for each layer. I have referred to this image from the Microsoft official site. Other than the layers, there are other components that will be involved in this type of entire architecture model to support the business requirements. For a better understanding of this multi-tier architecture pattern, I have organized the components of our imaginary e-commerce application, which was discussed in our SDLC module. To make it simple, I did not include so many tiers and components. The purpose here to understand how these layers correlate to the actual business functions. Here, we basically have three main components. In web server, we generally will have some of the static content of the application like images, JavaScript files, etc. Based on the request from the client, the web server will serve the pages to the user. All the required services and application logic will reside in the application server. In our e-commerce application, services like user registration, authentication service, search, checkout, and payment service logics will be organized in the application server. Finally, the database server holds the required data for this application. If we translate these components in our layered terminology, as usual, clients will hold the presentation layer, the application server will hold the business logic layer, and the database server will hold the data layer. The web server is an additional component introduced here to reduce some of the load from the application server. I hope now you have a better understanding of multi-tier architecture. In case anything is not clear, please feel free to mention it in the comment section. As with other architecture patterns, this model will also have some advantages and disadvantages. Let's quickly look at them now. In this type of architecture, the application will be divided into different tiers. It gives development teams the ability to develop and enhance the product with greater speed. Many development teams have separate developers who specialize in front-end, back-end, and database back-end development. Here, Here, any tier can be scaled independently of the others as needed. That means if we want to increase the number of database servers, we can easily do that without affecting either of the two tiers. Because each tier operates on its own infrastructure, it's possible to enforce different levels of protection. With this kind of implementation, clients cannot interact with the database directly. Now let's look at their disadvantages. A large number of tiers means more networks and devices associated with the system. This may cause slow performance of the application, particularly if the network bandwidth and hardware specifications aren't high enough. It is expensive as we will have multiple tiers in the architecture and each tier will have its own hardware cost. Now let's look at microservices architecture pattern. In this architecture pattern, the application is built as a suite of microservices. So what is microservice? Microservice is a small independent service that communicates over well-defined APIs. Each microservice performs a single function of the application. For example, the user registration function can be built as an independent microservice. Similarly, to manage authentication functionalities, we can have another authentication microservice. These services communicate via a well-defined interface using lightweight APIs. Microservices architecture will help large teams to build scalable applications. Since microservices are loosely coupled, that is, independent of each other, each service will be organized to handle specific function inside a large application. These services will communicate internally with other services. They can also be deployed independently. The key component in this architecture is API gateway. It receives requests from different clients and routes them to the relevant service. In addition to that, each service will have dedicated DB that manages the data of that specific service. These days, the microservices are deployed as containers. If you are not sure about the container, please watch episode number 5 in this series. Let's redesign our imaginary e-commerce application in the microservices architecture. In the multi-tier model, all the application functionalities are bundled in the business logic layer. So, in this microservices architecture model, those functionalities are developed and deployed as independent microservices. So, you can see a separate service for each functionality. This will make the business logic layer as loosely coupled and the teams can focus on the independent service. So, same with other models, we will have clients who actually send the request to the application via the internet. Those requests will be received by API gateway, which will transfer them to specific service and send the response back to the client. API gateway is an entry point for user requests. In general, these requests will be in the form of APIs. There are many other benefits of the API gateway component. Since this video only focuses on architecture patterns, I'm just skipping the granular details of API gateway. As I said in my previous slide, each service will have a dedicated DB which manages the required data of the service. For example, the payment DB stores all the data related to the payment transaction. Now let's look at some of the advantages and disadvantages of this model. In this architecture, the application will be built as independent microservices. So, independent teams take ownership of the services and work more quickly. This will definitely reduce the application development cycle times. Since the application is divided into independent modules, the teams can reuse them easily for different purposes. This type of architecture allows each service to scale independently based on the need without impacting any other service. This model increases the application resistance to failure. In the monolithic model, a single service failure causes the entire applications to fail. However, in this model, we can easily handle the service failures without bringing the entire application to down. When it comes to the disadvantages, it is more complicated than most monolithic applications. And these services involve a lot more moving parts than traditional applications. Therefore, they require enormous effort and careful planning to ensure proper communication, monitoring, testing, and deployment process run smoothly. With this model, achieving data consistency is a real challenge as each service has its own database and transaction management system. Services will need to communicate with each other, which results in a high volume of remote calls. This can increase network latency and processing cost. Now let's talk about our next architecture pattern, which is event-driven architecture. So what is event-driven architecture? Before going into any further details with this model, let's consider a real-time example. In any e-commerce system, when someone ordered any item, a set of direct calls will happen behind the scenes, such as triggering an email service that will send an email to the customer with the order details. Inventory services will be invoked to notify about the new order so that they will look for the item and hand over it to the fulfillment team for delivery. Order history services will also be triggered, which will update the records of both customer and company. Here, the downstream services such as email service, inventory service, and order history service are tightly coupled with the e-commerce system. That means e-commerce system will tell the services to complete their action and wait for the responses from them. For some reason, if any of those downstream fails, then the overall transaction will also fail. The e-commerce system should also need to manage the logic of resending the request to the service in case they did not respond in the first attempt. To address this type type of challenges in the system, event-driven architecture evolved. In this event-driven architecture, we would eliminate the dependency by introducing a new component called event broker. So the event broker will receive the events from the producer, nothing but the e-commerce system, and push them to the consumer, that is downstream services. Here the event means an action. It can be anything like login to the application, ordering an item, canceling an item. The consumers will subscribe to the events that they are interested in, and the event broker will only send the subscribed events to the respective consumers. So this will help us to decouple the architecture and also avoid those dependencies. In this type of model, the e-commerce system does not need to make several calls directly to the downstream services whenever a new order is received from the customer. Instead, it will push the event to the event broker. In addition to that, it will not wait for the response from the downstream. Then the event broker will ensure by pushing those events to the respective consumers. Once the consumers complete his action, it will acknowledge back to the event broker. So here as well, the same action is achieved with a different approach, right? Now let's look at some of the advantages and disadvantages. Decoupling is a key advantage in the architecture pattern. So here the main system no longer need to know about different downstream services. They only need to know about the event, and the event broker will send the right events to the subscribed consumers. In the traditional model, if one service fails, it will cause other service or even the entire system to fail. However, in this model, the event broker will keep the event and send it back to the consumer once it is back online. This avoids a single point of failure. Decoupling simplifies the process of scaling the producers or consumers to meet the client requirements. So we can easily add or remove the producers or consumers. Now let's look at some of the disadvantages. The middle component between the producer and consumer may cause the performance degradation, which results in longer execution times for the consumer. In this pattern, the subscribed consumer may process the events at different times based on the different factors. That means not all reactions happen to the event at the same time. This may cause some inconsistencies between the transactions. Now let's look at serverless architecture pattern, which is our final pattern in this video. So what is serverless architecture? Does it mean no servers in the architecture? Serverless does not mean that there are no servers. It actually means that the developers don't need to care about the servers behind the scene. The servers will run somewhere and we don't need to worry about creating and maintaining the infrastructure. Developers will write the code and cloud providers will manage the rest. These days, all cloud providers are offering function as services feature. In this model, we will run our code as functions. A function is a single unit of deployment of the code. These functions will be triggered by events. In general, they will have event-driven architecture which runs different services based on the application requirements. From this event-driven architecture, events will be emitted and those events will be triggered by the functions which run our code actually. To explain the architecture, I have referred the architecture image from the AWS website. This application architecture uses different AWS services such as AWS Lambda, Amazon API Gateway, Amazon DynamoDB, Amazon Cognito, and AWS Amplify Console. Amplify Console provides continuous deployment and hosting of static web resources including HTML, CSS, JavaScript, and images files which are loaded in the user's browser. Then the JavaScript will execute the browser and it will send and receive the data from the backend API built using Lambda and API Gateway. Amazon Cognito provides user authentication functions to secure the backend API. Finally, DynamoDB, in which data can be stored by the API's Lambda function. Here, the AWS Lambda is a function in which the actual logic will be deployed. The function will be triggered by the API calls through API Gateway. Managing the infrastructure of the AWS Lambda function is AWS responsibility. We only will pay for the number of invocations made to the AWS Lambda function. I hope you got some idea about the serverless architecture. Now let's look at some of the advantages and disadvantages. Cloud providers charge you on a per invocation basis, so you are not paying for unused servers or virtual machines. Based on the traffic variations, the function instances are automatically created or removed. The application team don't need to worry about the infrastructure. Instead, they simply develop the function and deploy it. This will definitely increase the delivery cycles of the organization, which increases the productivity. Now let's look at some of the disadvantages. In the serverless architecture model, you will lose the control of the infrastructure that your code runs on. If something happens in the infrastructure, you are dependent on the cloud providers to fix it. In general, the cloud provider will share the same infrastructure with different organizations. If the shared server isn't configured properly, then the application data could be exposed. As a performance testers, we need to understand architecture pattern and different components that are involved in the architecture and how the data flow from start to end. This will definitely help us to design the performance testing scenarios effectively. In addition to that, we also need to understand the ways to monitor these components so that in case of any issues during the testing, we can easily pinpoint the problem. During our performance testing project initial phases, we mostly work with the solution architect as they have a complete idea of their application. In the past, most of the applications were in 3-tier or n-tier model. model. So our testing approach was pretty much similar for most of the applications. As the technology getting evolved, like microservices architecture and event-driven models, we also need to change and design the testing approach to meet the client non-functional requirements. For example, in the past, we always identify the critical functionalities of the web application and design the testing around it. But these days, we may need to test individual APIs or push the required number of events to the target system and assess the performance. That's why I have tried to explain the different architecture patterns of the application. So that's it for this video. Thank you so much for staying till the end and supporting me. I hope you understand all these concepts in this video. In case of any specific concept is not clear or require more detailed information, please feel free to mention it in the comment section. If you are new to our channel, please consider subscribing and also like and share this video so that others will also get benefited. I'll see you with our final video of this module number 3. Until then, take care, stay safe and keep learning.